Today, we are going to make the ultimate mobile retro game console. And the best part is, you probably already own the most important component in this whole project. In fact, if YouTube analytics are anything to go by, you're probably watching this video on it right now. That's right. Modern day phones are actually pretty competent little emulation machines capable of playing all your favorite childhood hits. They've got bright, high refresh rate OLED screens, wireless connectivity, and powerful enough GPU and CPUs that you can play even modern day game consoles like the PlayStation 2 and the Nintendo GameCube. Just plug a game controller like this Razer Kishi here into your phone and you're basically good to go. Video over, and I will see you guys in the next one. Or, well, not quite. Yes, you could legitimately do that, but it would be like a 7 out of 10 experience. Your battery life would be kind of crappy. This whole thing feels kind of cheap and creaky. And once your CPU starts to thermal throttle, you're gonna notice some performance issues. And I did promise you guys the ultimate mobile retro game console, right? So today we're gonna put our DIY skills to use and we're gonna try and craft something that's a little bit closer to a 10 out of 10 experience. In fact, I actually went out and purchased a second phone specifically for this project because by the time we're done with it, it's not gonna function very well as a phone anymore. Now, that might seem like an annoying YouTuber flex, but I actually got this Samsung S21 FE, which is in mint condition and has some pretty top-end specs for 250 Canadian dollars. So it didn't exactly break the bank. And I will tell you exactly how I did it and how you can do it at home, but first, we have to start disassembling this thing. It all starts with a super evil scam. People will sell you a phone and then report that same phone as stolen to their carriers in order to get reimbursed for it. The carrier will then put the phone on a blacklist so that it can't connect to any cell networks, which effectively renders it useless as a phone. It's super shitty, but it does create an opportunity to give these crippled phones a second life as game consoles. Just search blacklisted phone on your local online marketplace and you are bound to find a bunch of really good deals. Okay, so now that we have the back cover off of this thing, let's take a look at some of these internal components and then we can discuss our plans for this project. So this big silver guy right here, that's obviously our battery. Then you have the camera modules over here, little daughter board down here that's responsible for charging. And then this guy right here, I think is the SoC, or in other words, the GPU, CPU, and RAM for the entire phone. Now, what I would like to do is take a second battery and add it right about there, a little something like that. And then I'd also like to create a little custom heatsink that's gonna take some of the heat away from what I think is the SoC. But here's the thing, I don't actually know that that's the SoC. So what I'm gonna do is use Mr. Thermal Camera here on my other phone, and we're gonna boot this one up and see if that area gets hot. Now, one interesting little quirk of thermal cameras is that they can't really read reflective surfaces. So I'm actually just gonna put a little bit of electrical tape on the back side of the little heat spreader that's on the SoC. Okay, yeah, I'm gonna go ahead and assume that that's either the SoC or the SoC is directly below that point because that is by far the hottest point anywhere on there. So we are gonna concentrate all of our cooling right on that little point right there. With that mystery solved, I was free to move on to designing the most important part of this whole project, the sled. The sled is a mid-frame that will allow the phone, its new heatsink, and the bigger battery to integrate more tightly with the Razer Kishi. In theory, it should make the whole setup feel like one solid unit. So I spent the rest of the day 3D modeling, 3D printing, and trying to come up with the perfect design for the sled. It took more than a few attempts. Alrighty. Now that we are done designing the sled over the course of many iterations, actually, you know what? Why don't I show you just how many iterations there were? Yeah, that many. We are now ready to move on to the next stage of this project, which is going to be designing the custom heatsink. But first, a word about iterating. Each one of these sleds represents a small step towards my idea of perfection on this project. And this is my favorite way to design things. Rather than trying to get it all perfect in the first attempt, you can just kind of sneak up on perfection. And in point of fact, there's still one last iteration I want to do, but we're gonna save that for a little bit later in the project. Over here on this table, we have a couple of copper sheets. You might remember these from my last project. Some copper shims here, and this copper M.2 heatsink. And what we're gonna do is combine these using a technique that I've never done before, called brazing. Put simply, brazing is the act of joining together two or more pieces of metal using a filler metal, most commonly solder. But before I could do that, I had to, cut my pieces of copper. And the nice thing about copper is that it's actually quite soft, so you can easily cut it with a jigsaw. Just make sure you have some fine-toothed metal cutting blades. If you need some, I've linked the ones that I used as well as all the other tools shown in this video in the video description. Finally, it was time to actually start brazing. I applied a layer of flux to my first copper sheet, laid the M.2 heatsink in position, and applied heat. Once the metal was sufficiently hot, this allowed
the lead-free solder to melt on contact and be brought into the joint by capillary action.
Sorry, I don't know what happened to my voice there. From there, it was just a matter of adding additional layers of copper. By using 1mm thick pieces, I was able to easily dial in the perfect Z-axis dimension for my heatsink. Maybe one day I'll be able to machine something like this out of a solid block of copper, but for now, this backyard solution seemed to actually work quite well. Once I had the rough shape I wanted, I used a fine metal file to remove any excess solder, round over my edges, and just kind of dial things in a little bit. And then I finished it off by using a polishing pad to remove all the discoloration caused by the heat.
Whew, would you look at that? That is our new custom heatsink. So again, the idea is that it's gonna go right here and it's gonna wick heat away from the SoC and then dissipate it into the rest of the room. And honestly, even if it doesn't work exactly the way I intended, it's still a huge thermal mass that's going to at least act like, well, a big thermal mass that will absorb a lot of heat coming off the processor. So now that this is done, let's move on to the next thing that I'm frankly very nervous about doing because I've never even seen anybody else do something like this before.
But first, let me tell you about the sponsor of today's video.
Me. And the best part is you can't even skip this ad read because it's already over. Let's get back to the build. So you remember earlier how I said one of the biggest issues with doing this is that you would burn through a normal phone's battery really quickly? Well, in order to fix that issue, we are going to make what I like to call a double battery. Or we're just gonna run two batteries in parallel. I bought two replacement batteries here and I'm gonna try and create a custom wiring harness that will effectively give us a battery that is twice as big and double our battery life. I just have no idea if it's gonna work or not, so this will be fun.
First off, do not do this at home. Messing with batteries is dangerous and they can very easily catch fire on you. I do these things in the controlled environment that is my workshop so that you don't have to. I started by removing the battery management board from the first battery. Sounds like a bad idea, but we'll talk about why in a second. This left two exposed terminals ready to be connected to the second battery. But keep in mind, before I started this whole mad science experiment, I made sure that both batteries were charged to the same level. If you skip this step, the batteries will rapidly equalize when you first connect them and bad things will happen. With my insulating electrical tape in place, I then routed the wires from the first battery up, around, and to the battery management board on the second battery. Now, I'm not sure why, but for some reason, these boards have conveniently located auxiliary contact pads. So all I had to do was solder the ends of my wire to those pads, and boom, I had two batteries wired in parallel, giving me twice the capacity at the same voltage. Then, I almost blew up the whole phone. You see, I had to get the original battery out. So off came all of these connectors, and then I had to use some isopropyl alcohol to dissolve the glue holding the battery in place. But I still had to pry it out, and if you look closely here, you can see that I actually punctured the battery with my pry tool. Normally, this would cause a runaway reaction resulting in a fire. But lucky for me, I had the good sense to completely drain the battery before starting all of this, so all I got was a little sizzling sound. Definitely a close call though. With the old battery out, I slid the new one in position, temporarily taped it in place, and then held my breath as I attempted to boot the phone for the very first time.
Ready to see if this crazy contraption works. Now hold it. It works. It actually works. That's such a relief. Now that we are done our double battery and our custom heatsink, we can move on to the last step of this project and the one that I kind of set aside earlier. We are going to do the last iteration of the sled or the case. And of course, because this is one of my videos, we're gonna make it a walnut.
3D printers versus CNCs. Which is better? Well, the boring truth is that they both have their advantages. But thanks to a new software update on my Xcarve, the workflow for the two is remarkably similar. Easel 3D gives me the ability to import SDL files and figure out toolpaths from those. Practically, this means that I was able to take the exact same files from my 3D printer and just plug them into my Xcarve. The only difference is now I'm carving down to the shape that I wanted through subtractive manufacturing rather than additive manufacturing. Pretty neat, right? So while the CNC did its thing, I busied myself with another job, making sure that the phone didn't short itself out on that new heatsink using Kapton tape. This special tape is heat resistant up to 200 degrees and creates a non-conductive barrier, so I just put it everywhere that the SoC wasn't. This should help to keep all my little circuits safe. So now that that prep work is out of the way, we can start thinking about assembly. And I have to be careful about how I do this because, well, it's only gonna go together one way, and if I get it wrong, then I'll have to start over, which I really don't wanna do. First things first, heatsink has to get installed in this bottom piece here. And in order to do that, I just use a little dab of silicone, which we'll talk more about in a second. But first, I added a few layers of electrical tape to insulate the backside of the heatsink from the battery. Then I glued that section to the top of the sled with some good old-fashioned wood glue, clamped it in place, and let it sit for an hour. I then repeated the same process with the other side and let the glue set up. Pop these clamps off. It's been about 30 minutes. There we go. Look at that. That is actually quite pretty. Before we move on to installing the actual phone, I think we need to spend a little bit of time sanding and then applying a little bit of finish to this thing. This is my favorite trick for sanding small parts. By taping the sandpaper to my workbench, I was able to reference its flat surface and sand out any seams left from the glue up. And while I was at it, I also rounded over a few hard edges left from the CNC. Then I applied a couple of quick coats of polyurethane finish. This will seal the wood and help to keep it stable over time by preventing it from absorbing any moisture from the air. So now we're ready to basically start assembling this thing. And I'm sure one question many of you have at this point is how exactly I'm gonna get heat from the SoC packet here to my new heatsink. Well, I'm glad you asked the question because I have a very special product that I wanna show you guys. It's this stuff right here, K5 Pro Thermal Putty. You can kind of think of this stuff as like a very viscous thermal pad. So I'm just gonna take a very healthy dollop of it, apply it to the SoC, and then we're gonna kind of smush the two together and it's gonna eliminate any air gap between the two and facilitate heat transfer from the SoC to the new heatsink that I made. See if it works. Should, but you never know. I've used this stuff on my laptop, actually I used it on the Everything Console Mark II. It's really handy stuff if you ever had to work on an old computer. Applying this stuff is honestly pretty funny. It literally just comes with a purple popsicle stick and you spread it on like it was peanut butter. And it's better to err on the side of adding too much, as any excess will just kind of get smushed out the sides. Now, this stuff is good for filling gaps up to about 2 millimeters, but anything above that and you'll want to add some copper shims into the mix to help facilitate better heat transfer. All right, let's do a little contact test before we go any further. Oh, of course, the phone's been on the entire time I've been working on it. Oops, push this in here. Still a nice tight fit. You can really see the paste just squeezing out of there. So I am not worried about that being a bad contact. That's great. Actually, you know what? This K5 Pro is actually a pretty decent adhesive. I'm having a hard time separating the heatsink from the SoC. Oh, there we go. Look at that. Okay, now let's talk about how we are going to adhere the phone to the sled. And the answer is more silicone. Silicone is a seriously underrated adhesive. For starters, it's really good at filling in little gaps. So once I put the phone into the sled, it'll squish down, spread out, and fill in all of those little crevices. Second, silicone provides a good strong bond, but I would classify it more as like a semi-permanent adhesive. If for any reason something breaks in the future, I know that I can pull the phone out of the sled with a little bit of elbow grease. And then finally, it's thermally resistant, so it won't deform or lose adhesion if it heats up a little bit. My only regret here is that I used white instead of clear silicone, but that's a pretty minor issue compared to some of the other things that we'll talk about at the end of this video during the post-mortem analysis. All right, it's about 30 minutes later, and now I'd like to do basically the same thing to the Razer key sheet. So my hope here is that this is going to take a lot of the kind of twistiness and just overall cheap feeling of this thing out of it by making it into one solid unit. I tried to make my tolerances really tight, so hopefully I won't need that much adhesive, and yeah, see how it goes. I know you guys have probably heard enough about it, but one other benefit of silicone is that it's really good at bonding dissimilar surfaces together. So if you have a porous material like wood and you want to bond it to a smooth surface like plastic, it'll get the job done for you. All right, that's it, I promise. At this point, I left everything to cure and then headed home to set up all of the software. So here we are back in the office, and I finally got all the software up and running on this thing. It actually took me a little bit longer than I expected it to, but hey, that's all in the past now, and I cannot wait to show you what this thing is capable of. It had actually kind of exceeded my own expectations in a lot of ways. But before we get to that, I want to talk to you guys real quickly about this whole self-sponsored video thing. Every time I do one of these everything console projects, there's always a ton of people in the comments asking me to do a specific walkthrough of the software that I used. And trust me, I'm pretty sure that would make for the world's most boring video. So what I'm gonna do instead is create and sell a digital guide that has all of the information that you will need to get this level of emulation up and running on your own Android phone. I'll even organize it by console so that you can get exactly the information you need for the games that you want to play. This will be my first time ever doing a digital product, and my hope is that I can use this to replace conventional sponsorship. So if you want to support the channel, check out the link in the video description. And without further ado, let's talk about all the fun stuff that this guy can do, because it's a lot. First of all, for all the emulation, I'm using a front-end software called Daisho. This helps to keep things organized. It's really handy if you're running like 10 different emulators the way I am. Basically, it's just a launcher. So you pick the game that you want to play, and then Daisho launches the right emulator, configures all your settings, and then loads up the ROM. It also automatically downloads all the box art for your games. I love that feature. All right, so now let's talk about what it can emulate. And as it turns out, it's quite a lot because the Snapdragon 888 is pretty damn powerful. To save time, let's just say that anything made before the turn of the millennium is gonna run flawlessly on this machine. And it's also capable of emulating more modern day consoles like the Nintendo GameCube, the PlayStation 2, and even the Nintendo Wii. And because of the new and improved heatsink, I haven't experienced any drops in performance even during long play sessions. And the cool thing is, you can actually feel it working. It never really gets hot to the touch because honestly, this setup is complete overkill, but it does get warm when you're really pushing the system. The SoC stays pretty much pinned in the low to mid 40s, so you are always getting full performance. And speaking of performance, battery life. Yeah, it's pretty great. With almost 9,000 milliamp hours on tap, your hand is gonna cramp up long before this thing runs out of juice. And I think that brings me nicely to my next point. There is a trade-off to be made for all that added power. This thing is a chunky boy. Tipping the scales at 507 grams, it's almost 25% heavier than my Switch OLED. But honestly, I don't really mind. This thing feels well built and substantial in the hand. And a big part of that is the fact that it just doesn't creak and rattle anymore. So yeah, I'd say that's a small trade-off. Now, let's talk about some of the sweet bonus features of this device. Because it's an Android phone at the end of the day, you have access to all the Android games that are out there. And honestly, I was surprised at the breadth of what's available. I guess I never really looked into it before, but yeah, there's a ton of original content, and there's also a bunch of re-release classics. And then there's game streaming. For instance, I can use Steam Link to render the latest and greatest AAA games on my big computer and then just stream them to the handheld. Or if you're more of a couch-style console gamer, well then you can just pay Microsoft $15 a month, have them render the game and stream it to you. See, I'm actually playing Halo Infinite on this thing. And it can also do basically every other Xbox title. Oh yeah. And then one last thing. I did manage to get Nintendo Switch emulation working on this thing. Now, the performance isn't quite there. Breath of the Wild struggles to hit 30 FPS, but some less demanding games do run quite well. So, overall, very happy and very excited about what this thing is capable of. But now, let's talk about what I could have done to make this thing even better in the post-mortem analysis. Number one, and this is a big one, I shouldn't have used a damn Samsung phone for this project. I didn't know this when I started the project, but Samsung really locked down their phones in North America, and that means that I can't root this thing, which means that I can't overclock this thing, which is really egregious because given the performance of this cooler, I know that there's a ton of headroom here for overclocking, and I'm leaving a ton of performance on the table. That's really annoying. Number two, making the sled out of wood. Probably not the best choice. I'm sure there's a lot of people in the comments who are saying that this thing is a complete fire hazard, but honestly, I don't think that's true. I just mean from a materials perspective. Wood is not the most stable material when you get it down to like 1 millimeter in thickness. Had I 3D printed the whole sled out of PLA or even PETG, I could have worked to a higher level of precision and made the whole thing more stable. That being said, I do really love the look of the walnut, and it did work, so I don't know, maybe it's not that big a deal. And then finally, this last one isn't too bad, but I do think it's worth mentioning. The Razer Kishi does not allow you to transfer data through its USB port. It's only for charging. While this is a little bit annoying, it did push me to come up with a solution, and I am now using my own file server to wirelessly transfer games and data to the phone. So, you know, lemons and lemonade. In my next video, I am going to fix the biggest problem with my laptop and do what the engineers at Dell were obviously too cowardly to do. Make sure to check out my Android emulation guide, and I will see you guys in the next video. Peace.